Regular self-testing of your chemistry knowledge is crucial to success in your A-level. In this video, I'll be helping you with a retrieval practice technique known as blurting, and how this can coach you to develop some seriously good thinking skills ahead of your exams as part of your regular revision. Shortly, I'm going to give you a blurting prompt, which will be a single word or sentence related to your chemistry A-level. You then need to set yourself a time limit, and within the time you have, write down as much as possible that you can recall about the topic that I've set from all across your A-level. Don't use any study resources and don't communicate with anyone else during the time you have. Quickly check out the video description for some tips on the kinds of things that you could put on the page, with a lot of emphasis here on dual coding where possible. When your time is up, unpause this video and I'll take you through the themes you could have hit on in your writing to see where your successes and gaps are with the course content. So your blurting prompt for today is going to be the H+ ion. So set yourself that timer and think about where the H+ ion comes up in various contexts across your A-level in chemistry. Pause the video now and come back when your time is up. Okay everyone, welcome back, and let's take a look at where the H+ ion comes up most in the A-level. Sprinkled across modules 3, 4 and 6 on the OCR-A specification, we definitely see the H+ ion mainly come up as a catalyst, but let's have a look at module 3 to begin with. Here we use the H+ ion to test for carbonate ions in an ionic equation, and that produces effervescence of CO2. And the usual source of the H+ is nitric acid, because that doesn't contain any additional ions that we may later need to test for. For example, if you try and use HCl there, well, that contains chloride ions, and you don't want to introduce an ion that you potentially later need to test for. So typically it's nitric acid that we use as our H+ ion source there. In modules 4 and 6, as I just mentioned, typically here we're looking at catalysts. We've got alkene to and from the alcohol, which uses either sulfuric or phosphoric acid. And we've also got esterification and hydrolysis, which both use H+ ion catalyst as well, usually again in the form of H2SO4 this time. We've also got that the H+ ion is present in the acidified potassium dichromate solution, not as a catalyst, but as part of the reaction in order to oxidize primary and secondary alcohols and aldehydes to various different products. Remember that tertiary alcohols do not oxidize, so that's why I've not mentioned them in that list. Now, Module 5 has got a lot more to say, because of course in Module 5 of the A-level, we're going to meet the pH calculation, which is negative log of the H+ ion concentration. And as you can see here, we need to be able to calculate the pH of all of the following types of solution. We've got the strong monobasic acid, we've got weak acids, and we've got pure water followed by strong bases and then weak acid buffers. That's quite a big list. You need to be able to calculate the H+ ion concentration for all of those solutions, and then once you've got that quantity, you can just negative log that value to the base 10, and that's going to tell you the pH of that solution. Your job in the exam is to identify what kind of solution you're looking at, so you know which of these correct H+ ion concentration calculations to be using. Right at the bottom of the list here, you've got the standard hydrogen electrode, and this uses a 1 mole per decimeter cubed solution of H+ ions, usually from something like HCl, and their presence in the solution for the half equation equilibrium. Do you think I missed anything from this list? Why don't you let me know in the comments down below, and then we can add things into the video description so that lots of people can benefit from your chemistry knowledge as well. If you'd like to do another one of these videos, then there are some links on screen now that'll take you to the one that's present for catalysts. And if you found this video helpful and you'd like to see more of this style, then please again leave a comment down below, and don't forget to like this video before you go to support my channel. Until next time though everybody, happy revising.